Hello everyone, this is Ritupriya Pandey and today I'll be teaching you about the topic the interior of the earth. So let's get started with the topic. So first we should know what is the shape of the earth. The shape of the earth is oblate spheroid. Oblate spheroid means it is flattened at both the poles, at north pole as well as south pole. It is flattened at both the poles and at center it bulges out. It's bulging. So that's why it is known as oblate spheroid, means it is spherical but not totally round. For example, if you have football, so just press it from upper side as well as from lower side. So what you will see, it gets flattened at both the side and it bulges out at the center of it. Okay, so this is the shape of the earth and its radius is 6400 kilometer approximately, and if we talk about the specific value, then it is 6370 kilometer. So before going about the detail of the interior of the earth, we should note that till date no one has reached till the interior of the earth. So whatever the evidences we are having about the interior of the earth, about the composition of the earth, about the different layers of the earth, it's all because of the indirect evidences. About the indirect evidences we will be talking later on in this chapter only. Okay. So here you can see the configuration of the surface of the earth is largely the product of exogenic as well as endogenic processes. Exogenic processes like wind, meandering of rivers, erosion, these are all, and many more, these are all known as exogenic processes which occur on the surface of the earth. And the processes which occur inside the earth, they are known as endogenic processes, for example volcanic activity and many more. Now we come to the topic interior of the earth. So first here you see this is the shape of the earth, oblate spheroid. Okay. Now here you can see different layers of the earth. You can imagine it by taking a slice of cake. Means you are taking out a slice of cake and just see that slice. It's V shape, okay, and suppose it's a slice of the cake, imagine, and this is V shape, though it's my pencil, it's straight only, it's not V shape, but just imagine. Okay, so this is the crust, upper layer, then below crust it's mantle, then below mantle it's core. Okay, and it is all because of the composition of the earth, different composition of the earth, different densities, different temperature, different pressure which are over there, because as we go inside the earth, okay, so with increase in the depth of the earth, the temperature as well as pressure both increases, and not only temperature and pressure, even the density also increases as we move into the interior of the earth. Okay, so now here you can see we have written mechanically the interior of the earth. Mechanically means physically. What we see means like, is it solid, liquid, gas or viscous? According to that physical appearance, we have different layers. Okay, and these layers are lithosphere, asthenosphere, mesospheric mantle, outer core and inner core. I will be dealing with all of these layers in detail later on. Then chemically the earth can be divided into, chemically means upon different chemical composition. It is divided into crust, mantle, lower mantle, outer and inner core. Then here you can see crust. Here you can see this is oceanic crust and this is continental crust. You can see the difference between the thickness of the oceanic crust and the thickness of the continental crust. Oceanic crust is much thinner than the continental crust. It is about only 5 kilometer, while the continental crust thickness varies. It varies up till 70 kilometer or 100 kilometer also somewhere. Means it depends, because continental crust gets more thicker in the mountainous region. That's why its thickness varies. And the density of the oceanic crust is more than the density of the continental crust. For example, the density of the oceanic crust is 3 gram per centimeter cube, while the density of the continental crust is 2.7 gram per centimeter cube. And due to which you can see here there is one plate and here it is another plate. if not plate, you can see this is oceanic crust and this is continental crust, and the density of the oceanic crust is higher than the continental crust. That's why the oceanic crust gets subducted under the continental crust. Okay, and now here one more thing you are seeing, it is lithosphere. Lithosphere means it is the crust plus upper mantle. When crust and upper mantle comes together, it's known as lithosphere. So this is all about the crust, and in detail we are going to study now. Oceanic crust is 5 kilometer and is mafic rich. I have told you earlier only that it is only 5 kilometer in thickness, and it is mafic rich. Mafic rich means it is rich in magnesium and iron. Its density is 3 gram per centimeter cube. The thicker crust is the continental crust. I have told you earlier only that continental crust is the thicker one, and it is rich in felsic. Felsic means feldspar and quartz, and its density is 2.7 gram per centimeter cube. The rocks of the crust fall into two categories, Sial and Sima. Sial means silicon and aluminium, and Sima means silicon and magnesium. Sial is found under the continental crust or under the land, while Sima is found under the ocean floor. And apart from that, now the scientists have discovered many more elements also, like oxygen, silica, aluminium, iron, calcium, magnesium, sodium and potassium. It is all in descending order, means maximum amount is of oxygen and the least amount is of potassium. Then here we move towards the mantle. Here you can see this is the mantle and this is asthenosphere. Okay, so what happens here? It extends up to the depth of, suppose this is crust, okay, it extends up to the depth of 70 or 100 kilometer. Then from 100 kilometer to 2900 kilometer, it is all about mantle. Okay, this whole area is covered by mantle layer. So the mantle is divided into upper and lower mantle separated by a transition zone, asthenosphere. Here you can see it's asthenosphere. This is upper mantle and this is lower mantle. And this upper mantle and this lower mantle is separated by a viscous and a weak layer known as the asthenosphere. This asthenosphere is weak layer and it is very viscous, due to which it is known as low velocity zone, because when the seismic waves like P waves and S waves come here, when they pass through it, their velocity decreases because of its viscous fluid nature. Okay, so now here you can see that we have two different types of mantle, upper mantle as well as lower mantle, separated by asthenosphere. Now not only this, here also there is a thickness of 200 kilometer layer, and this layer is known as D double prime layer. Okay, this D double prime layer, it connects mantle with the outer core. Here you can also see the transition layer of inner mantle. This is the inner mantle. Okay, this is inner mantle, and this is the transition between the inner mantle as well as the outer core, and this layer is known as double prime layer. There is some form of convection in the mantle, due to which mantle is more plastic and less solid or liquid. Okay, here what you see, this is convection cell which is going on. This is convection cycle which is going on under the mantle layer. In the mantle layer, here it's rising limb, here it's sinking limb, here it's advecting, and here it's moving towards rising limb once again. This is known as convection cell, and this is the reason, means this is the convection cell only due to which the mid-ocean Atlantic ridge or the mid-oceanic ridge is created in the Atlantic Ocean. Then we move towards the asthenosphere. As I have told you earlier also, that it is known as weak force, or it is also known as low velocity zone. Primary and secondary waves travel very slowly here. Then according to the scientists, crust and upper mantle, I have told you earlier only that crust and upper mantle together, they are known as lithosphere. Then after mantle, the third layer comes, which is known as core, and core is divided into again two layers, outer core as well as inner core. Outer core, here you can see this is outer core. It starts from 2900 kilometer up till 5100 kilometer, and it is liquid. You should know that it is liquid in nature. And inner core, it starts from 5100 kilometer and extends up to 6378 kilometer. Okay, and this is solid in nature. So outer core is liquid in nature, inner core is solid in nature, and due to this they have nickel as well as iron composition, and iron composition is more than the nickel composition, and together outer core and inner core together they are known as barosphere. And since their composition is of iron and nickel, so that's why they are responsible for the earth's magnetism. Although earth is not a permanent magnet, means earth doesn't have any permanent magnet, but still it is responsible for the earth's magnetism. And okay, one more thing over here. I have told you earlier only as we move down, the density, temperature as well as pressure all increases with increase in the depth. That's why the density of the inner core is maximum. It's 13.5 gram per centimeter cube, while the density of outer core is 10.7 gram per centimeter cube. Earth is not a permanent magnet, I have told you. It constantly produces dynamo and randomly reverses its polarity, unlike sun. Okay, so what happens? Sun reverses its polarity after every 11 years, but this is not the case with Earth. Earth, it depends. It may take million of years, it may take thousand of years. It depends on its dynamo. Okay, so here you can see this is North Pole of Earth, this is South Pole of Earth, but this is the geographical North Pole and this is the geographical South Pole of Earth, while the geographical magnetic North Pole is over here and magnetic South Pole is over here, just opposite. Means magnetic North Pole is at the geographical South Pole location, and the magnetic field comes out of the South Pole and moves towards the North Pole of the geographical area. Then apart from all these layers like crust, mantle, core with different compositions, we have different discontinuities also in these layers, and these discontinuities are mentioned over here. For example, you can see over here, this is Conrad discontinuity. It is found between the upper as well as upper and lower crust. Okay, this Conrad discontinuity is found between upper and lower crust. Then it's Mohorovic discontinuity. It is found between the lower crust and upper mantle. Mohorovic discontinuity is found between the lower crust and upper mantle. Then here it comes Rapiti discontinuity. It is found between the upper mantle and lower mantle. Then Gutenberg discontinuity is found between the lower mantle and outer core. Then Lehman discontinuity, it is found between the outer core and the inner core. These are all discontinuities. These discontinuities are dependent on different factors. Let it be composition, let it be gravity, let it be anything. Okay, these discontinuities are dependent on different factors. Then we are knowing about different layers, we are knowing about different composition, we are knowing about different discontinuities found in the interior of the earth. But how do we know about all these things? The most accurate, there are several other factors also, there are several other reasons also, but the most accurate according to the scientists is seismic wave. So seismic waves are the waves of energy that travel through the layers of the earth, means they travel through different layers of the earth, due to which we get different information. They are formed due to earthquake, volcano and etc. They are interchangeably used for earthquake. We always say that seismic waves are coming, we can feel the tremors, but This is interchange, means we are using it interchangeably with earthquake, although it is also associated with volcano and human activities also. Then what is seismology? Seismology is the science that studies various aspects of the seismic waves generated during the occurrence of the earthquakes. So here you can see, this is our earth, this is the interior of the earth, this is solid inner core and this is liquid outer core. This is solid inner core and this is liquid outer core. Here you can see we have different curves over here. Rays are getting refracted. There is nothing over here. So why is it so? It says that Earth is not a homogeneous in nature. It says that Earth is not a homogeneous in nature. That means if it would have been in homogeneous condition, then there would have been only straight lines in the interior of the Earth, and there would have been no diversion, no curve formation inside the Earth. But we can see there are curves formation, there are diversion also. That means Earth has heterogeneous nature. Then these seismic waves. Okay, we are going to talk about the types of the seismic waves. So there are two types of seismic waves. First is body waves and second is surface waves. Body waves, they are also divided into two types, means primary waves and secondary waves. Primary waves are also known as P waves, longitudinal waves or compressional waves. So they are similar to the sound waves. Similar to the sound waves means they travel to and fro. Means the particles of these waves, they travel in to and fro movement. Suppose this is the direction or this is the propagation of the rays. Okay, so what happens over here? The primary waves move like this. The primary waves move like this. Okay, that means it is traveling parallel to the direction of the propagation of the ray. It travels parallel to the direction of the propagation of the rays. And not only this, this is the fastest wave, and it is the first wave which arrive at the surface. They travel through solid, liquid and gaseous material. They travel with fastest speed in solid material. Although they travel in all the materials, let it be solid, gas, solid, liquid or gas, but they travel fastest through solid material. They propagate parallel to the direction of the waves and create density differences. This create density differences over here. So they move like this, to and fro movement. They are running parallel to the direction of the rays, and they are creating density differences. Then second is secondary waves, also known as S waves or transverse waves or distortional waves. Transverse waves because they are moving like this. They are moving like this. That means suppose this is the direction of the propagation of the rays, and if it is moving like this, that means it is moving perpendicular to the direction of the propagation of the rays. And not only this, it is creating crust and trough over here. You can see it is creating crust and trough over here. See, this is the direction of energy transfer, and this is longitudinal wave, means parallel, and so this is the energy transfer, and this is transverse wave, means perpendicular, creating crust and trough over here. And one more thing, the most important, S waves travel only in solid material and not in any liquid or gas material. It is slower than the primary waves. They propagate perpendicular to the direction of the waves and create trough and crust. Then second, here comes surface waves. Just a minute. Surface wave. Surface waves, they are also known as L waves or long period waves. They are most destructive waves. They cover the large area on the surface of the earth. That's why they are most destructive waves, and they generally affect the surface of the earth and die out at smaller depth. Means they cover large area, but their depth is very less. They are most destructive. They cover longest distance of all seismic waves. Okay, now here it comes the shadow zone. Earlier only I have shown you this diagram. that there is nothing over here. There is curve, there is refraction, there is waves coming over here, but there is nothing over here, there is nothing over here. So this area is known as shadow zone, and now we are going to study why this is shadow zone area and what is shadow zone area. So when earthquake occurs, seismic waves are recorded at epicenter. Epicenter, it is the place at which the earthquake event is felt first, and it is present on the surface of the earth and perpendicular to the focus. Perpendicular to the focus. About the focus I'll be telling you in detail when I will teach you about earthquake. Waves are reflected and refracted, passing through a body having heterogeneous composition and varying density. Therefore, there exist some specific areas where waves are not reported, known as shadow zone. Here, what you see, as I have already told you, that outer core, here, outer core is made up of liquid and inner core is made up of solid material. That means P waves are traveling over here. P waves are traveling here also, but after 103, here it is mentioned 103, but in NCRT it's 105 degree, means after 105 degree, or you can say 103 degree, which is mentioned over here, no S waves are found. No S waves are found means this whole area is the shadow region of the S wave. This whole area is the shadow region of the S wave, because this whole area here its liquid is there. So as we know, S waves travel only in solid medium. So solid medium is present up till here only, up till 103 degree or 105 degree, whatever you want to say. And beyond that there is no solid material. That's why there is no S waves over here. That's why it's shadow zone for the S waves. And for the P wave, this 103 degree to 142 degree, this is the P wave shadow zone area. Here the velocity decreases very much of the P waves. Now beyond here, now just go through the slide. Seismograph located at any distance within 105 degree P and S waves, means from here to here, P waves and S waves both are found, but after this only P waves are found and no S waves, and here even P waves are not also found. That's why it's known as P wave shadow zone area. So guys, this is all about the interior of the earth. We have come across different layers, their thickness, their composition, and not only this, the discontinuity and what are seismic waves and how they are distributed, what is shadow zone, what is the shadow zone of S waves, and what is the shadow zone of primary waves or P waves. This we have all read. But now let's move forward. Here we can see how the UPSC has asked questions about this topic. How the temperature varies towards the center from the earth surface. It increases. With reference to the structure of the earth, consider the following statements. The continental crust is thicker in the areas of major mountains. True. The upper portion of the crust is called as asthenosphere. No. Asthenosphere is present in mantle layer. And the outer core is in liquid state while the inner core is in solid state. It's true. How many above statements? It's not asking about which of the following statement is true. It's talking about how many numbers. Means how many numbers over there are right. So only two. Means first statement and second statement. They are true. Then the third question is the dash is responsible for Earth's magnetic field, outer core. What is the shadow zone of S waves? Here it's means they have given preference over the outer core, but you can say that outer core and inner core both are responsible for the Earth magnetism. What is the shadow zone of S waves in the interior of the earth? Beyond 103 degree or beyond 105 degree, whichever you are comfortable with, or whichever the option is given over here. Okay. So this is all about the interior of the earth. Thank you so much.